Now this is going to be how to do a simplification of a Markov model in TreeAge. I'm going to model this after the model they have for the life cycle of a tooth in the American Journal of Public Health article. They have some different states: sealed, extracted, restored. I just want to use two states. So to simplify it, we'll say there's two states: sealed and extracted. The tooth goes through these different years, and then each year the tooth could either loop back into the sealed state or it could become extracted. When you convert this state transition diagram into a Markov tree, you can see here that this looks more like the decision trees we were using in the other projects. And then you could connect that to how I'll show you by hand how what this loop structure does. This Markov model is really just a recursive tree. It's just a sort of expanding decision tree that goes through these multiple cycles. Now, normally it prompts us to configure the models. Because we started with a state transition diagram, I had to be more heavy-handed with TreeAge and go to the configuration model by hand. But the options we put are just the same, right? So now you can see on the bottom of the screen it says calc cost effectiveness, outcomes 1 and 2. We labeled those cost and effectiveness. We'd set the willingness to pay for $50,000 per quali. And what we have here in this Markov base, so that's this loop structure, that's the recursive one we had earlier. And now I'm just going to add a comparison sealant. So the comparison sealant, I'll just put the cost and quality there just to simplify it. We'll say we already know what it is. And then what we're modeling is this other sealant that's going to expand through this Markov tree, or this recursive tree, this loop structure. So we're choosing between two sealants, sealant A and sealant B. You can see that stage is the number of years or the number of cycles that it runs the model for. TreeAge defaults to 120 stages. I'm going to change that to 2. So 2 stages, it's just going to run it for cycles 0, 1, and 2 of the model. So just like how I showed you in my other video by hand. So now each year, remember each year, each stage of the Markov model, each stage of the loop structure, sealant A could either it could stay sealed or the tooth could become extracted. If it's extracted, you're done. If it stays sealed, then the next stage, there's a 75% chance that it loops back into sealed, 25% that it moves into extracted. And I'm just going to go to the Markov info for the sealant A here. So let's just say that sealant A has an initial upfront cost of $150. We'll put all of that cost right at the beginning of the model, and the final effectiveness, we'll just give it 1 quality. So we'll give the sealant or the tooth 1 quality adjusted life year at the end of the thing. So if it stays sealed at the end of the thing, it gets quality. If it's extracted, no quality. And now let's just run the basic Markov report. So this Markov report shows the different stages of the model. So this is like in the one where I show you by hand, where it's going through a recursive tree. Stage 0, 100% of them are sealed, 0% of them are extracted. Stage 1, 75% of them are sealed, 25% of them are extracted. Stage 2, less and less of them are sealed, more and more are extracted compared to stage 1. So each stage of the model, more of them are sealed, less and less are sealed, more and more of them are extracted. At 0.56, the cumulative effectiveness of the Markov model, that's what's going to go into cost effectiveness. So you see sealant A here, you can see right on the x-axis, the effectiveness, it's like 0.56. Right, that blue triangle, sealant A, that's the effectiveness after 2 years of the cycle. So remember the effectiveness, we gave it a quality at the beginning, but then that 0.75 is going to multiply through 0.75 times 0.75. That's 0.56. That cumulative effectiveness of the Markov cohort, that's the cumulative effectiveness. That's the effectiveness that goes into the ICER calculation here. So you see it puts sealant B $50, 0.2, that's just what we gave it, and then $150, but 0.56. That's 0.75 times 0.75 because of the 2 stages. So that 0.56, that's the cumulative effectiveness at the end of the Markov model. And it's going to choose sealant A here, more cost effective compared to sealant B.